Hi everybody, this video is about getting the surface area and volume of three-dimensional objects. Before we get into an example, quick definitions. Surface area is the total area of all surfaces, whereas volume is the capacity of a three-dimensional object to hold something, like liquids, gases, or etc. Before we get into an example also, I want to show you something very quickly over here. This is compliments of GeoGebra.org, a free website for everybody to use, where you can do amazing things like you're about to see right now. So this is a little demonstration of how volume works. So we have volume and we have surface area over here in cubic units for volume and in square units for centimeters. I want you to pay attention to the numbers as much as you can and the object itself. I'm going to manipulate something here, and when I do, you will see the volume will change as the surface area does as well. So take a look. So if I lower this down like this, and I make it real flat, so it's like a pancake, as much as I can, like that, you'll notice that this thing looks like a sheet of paper now, or like a two-dimensional object. The volume is almost nothing, and the surface area is a lot lower than it was before. If I were to take this, though, and raise it up, the volume increases rapidly, and this looks more and more like a box. And that's in fact what a box is. It's basically a base shape, in this case a rectangle, that is elevated by a height. And it's raised and raised and layered until you have an object in 3 dimensions that you can put stuff inside. So with that in mind, let's get back to our example. So in this example, we're going to calculate the surface area. Now to do that, you have to get the area of each visible surface. If a surface has duplicates, then you will multiply its area by how many there are. And finally, you will do the sum of all the areas. So let's go ahead and get into this and see what this looks like. So for the surface area, I have to consider what I'm looking at. So this is a rectangular prism. I know that because my measurements are different at the base. This here would be considered, we can call this the width. This could be called the length. And this over here would be the height of the entire object. Now, to calculate the surface area, what we have to consider is that there are duplicates of each of these 3 faces or surfaces that we can see. So I have this here that I can see, but there's also a duplicate of this, another surface just like that one, but it's at the back. Okay, it's at the back of it. It's right here. So I have to consider that. Likewise, I can do the same thing, same idea with all the other surfaces. I have a surface up here, but there's one also down there, okay? So I need to keep that in mind. And finally, I have a surface here, but I also have one over there, okay? So with those things in mind, let's go ahead and figure this out. So to get the surface area, first, I'm going to pick a surface to focus on. So the one I want to focus on is this front face right here. I know that the width of this is 5 millimeters. The height of it is 7, and I know that because this is 7 from here to here. And so if this is 7, then so is this. So I can call this 7 millimeters. So to get the area of that, all I have to do is remember the formula for the area of a rectangle. And that is simply the area of a rectangle is equal to the length multiplied by the width. Now, that's a standard formula, but you can replace length with height if you want. And in this case, we might have to do that because 7 millimeters is a height of this face right here. Okay, so we're going to replace length with height in this case. So the area of this will be 7 times 5. 7 times 5. That's 35 millimeters squared. Now I get the area of the other face. So this would be the area of this face would be 7 times 9, which is 63 millimeters squared. Finally, get the area of the top surface. So the area of this would equal. Now, it looks like nothing is labeled, but in reality, you have everything you need. So this side here would be the same as this side here, which is 9. So this is actually 9 millimeters. And this over here would be the width, and that, as we know from the bottom, is 5. So this is 5 millimeters. So if I want to get the area of this top surface, it's simply 9 times 5, which is 45. Okay, erasing this here. So 45 millimeters squared. Now, to get the surface area of the whole thing, remember, there are 2 of each surface. So when I know the area of each surface, all I have to do is double each one and then do the sum. So that's what happens next. So it's going to be 2 of my 35 millimeter squares plus 2 of my 63 millimeter squares plus 2 of my 45 millimeter squares. And now I just have to do some math. So 2 times 35 is 70 squared. 2 times 63 is 126 millimeters squared. And finally, 2 times 45 would be 90 millimeters squared. So to get the total for all this, you just add everything up. And what we get is, so 70 plus 126 plus 90 is 286. So this is 286 millimeters squared. And that would be the surface area for this object. And that's it, really. That's how to get the surface area of an object like this. Now, there are different types of prisms. There are different surfaces. Some are curved. We're doing surface area for a non-curved object, okay? But for rectangular or square prisms, this is it. Now for volume involves using a formula. So to get the volume of an object in 3 dimensions, you have to use a formula for the specific shape that you have. There are many different shapes, as I just said a moment ago. Therefore, there are many different formulas. For this particular shape that we're looking at, a rectangular prism, all we have to know is what's already given to you in the very beginning. So I can get rid of all this stuff in red and just focus on this, this, and this, because the formula for the volume of a rectangular prism is the following. It would be the length multiplied by the width multiplied by the height. And knowing that each of these variables have a number, all I have to do is substitute, multiply, and I'm finished. So the length here would be 9 millimeters, which will multiply with the width, which is 5 millimeters, which will multiply with the height, which is 7 millimeters. Okay, now this is just 9 times 5, which is 45, multiplied by 7. So 45 multiplied by 7 is 315. Now the units for this are still millimeters, but this is millimeters cubed, and there's a reason for that. This goes back to the laws of exponents. So consider this. X times x times x is x to the third power. For the same reason, when you multiply units like millimeters times millimeters times another millimeter, what you get is the same type of answer. You get millimeters to the third power, okay? For the same reason that x times x times x is x to the third power, millimeter times millimeter is millimeter cubed, and similarly, millimeter times millimeter is millimeter squared, which is why when we do area, you have powers of 2, but when we do volume, you have powers of 3. So with that in mind, I hope that this video helped you out. Please stop by, leave a comment, and as always, Thanks for taking the time to watch. Bye-bye.